Welcome to Chapter 4. So in Chapter 4 we are studying the Heckscher and Olin model of international trade, which explains trade patterns by reference to differences in countries. So unlike the Ricardo model, the Ricardian model, the Heckscher and Olin model explains differences between countries in terms of their factor endowment, that is, in terms of the availability of resources. So the Heckscher and Olin model that we will study in this chapter is suggesting that there are two countries which are each producing two goods, and these two goods are produced with two factors, two resources. So the Heckscher and Olin model is sometimes called the 2 by 2 by 2 model because we have two countries, two factors of production, and two outputs. So two inputs, two outputs, and two countries. The Heckscher and Olin model, that is quite a classical model, is suggesting that the factor in which a country is abundant in, relatively speaking abundant in, will determine the good that it will export. So if a good is relatively capital intensive, so it takes a lot of capital relative to labor to produce a good, a capital intensive good, if a country is relatively abundant in that good, the model predicts that that good will be exported and the other good, at least in part, will be imported. The usefulness or the beauty and the attraction of the model is that it will allow us to study in detail also not just positive economical question, that is relating to why certain countries are importing or exporting certain goods, but it will also allow us a analysis of a normative economic question, namely welfare analysis, that is, who is gaining and who is losing from trade. In this chapter, we will see that the Heckscher and Olin model is predicting that when a country starts to open up to the rest of the world, there will be one sector that will be exposed to competition from abroad. That is the import competing sector. The sector that the country will start importing goods into is the sector that will exhibit some, if you like, welfare losses, in the sense that the resource that is used in that sector in particular, so if that, for example, in the United States, if we have two sectors, a capital intensive sector and a labor intensive sector, if the United States, which is the fact, it is relatively capital abundant, the unskilled or less skilled sector that uses that, if you like, a lower skilled resource relatively intensively will be subject to competition from abroad once there's international trade. The winners from trade will be those factors of production, for example, capital or higher skilled workers whose products is being exported. And the lower skilled workers will be, if you like, exhibiting welfare gains or losses according to the Heckscher and Olin model. So the Heckscher and Olin model is very useful and it's interesting. We can take it to the data, and in the most simple basic case, Wassily Leontief, an economist, has found that in the most basic case, the Heckscher and Olin model needs to be adjusted in order to match some data in reality. Namely, we cannot merely just count the number of machines or the number of workers in a country to determine if a country is abundant or scarce in that resource or another resource. We have to adjust the number of, for example, workers or machines by their effectiveness. For example, in terms of workers, we can adjust it by the wage that is being paid to those workers, because it tends to be the case, according to studies, that the more productive a worker is, the more wage he or she receives. Similarly with machines. So that, if you like, wraps up the introduction to this chapter, in which we will study the Heckscher-Ohlin model, which is complementary to the Ricardian model, which we have already studied. So let's proceed to the lecture slides and study this second model of international trade. In this chapter, we are looking at the second main model of international trade, namely the Heckscher-Ohlin model. The questions that we would like to consider are: why is it the case that the US is exporting agricultural products and airplanes? Second, which country has the most capital, for example, in the form of factories, as compared with its GDP? So which country has abundance of capital relative to its GDP? And how does trade affect the earnings of the factors of production, labor, and capital? So these are some of the questions that we would like to consider in this chapter. So in contrast to the Ricardian model, which emphasizes productivity differences between different countries in terms of their productivity of producing certain goods, the Heckscher-Ohlin model is emphasizing instead the difference in the supply of resources that are available to a country. So, for instance, Canada has a lot of land, and therefore it is exporting goods that are related to land, including agricultural and forestry products, as well as petroleum. The United States, Western Europe, Japan have many highly skilled workers and a lot of capital. And these countries, the US and Western Europe and Japan, export goods that are related to those inputs, namely sophisticated services and manufactured goods, which rely on the use of capital in conjunction with highly skilled workers. Then, aside from this, you have China and other Asian countries that have a large number of workers and moderate but growing amounts of capital, and they export less sophisticated manufactured goods. So, in other words, you can speak of the different resources. Alternatively, you can look at the products and examine, for example, agricultural products or forestry products and see if they are intensive, relatively speaking, in the use of that factor of production or another factor of production. So, for example, agriculture and forestry products are intensive in the use of land, relatively speaking, compared with other products, so other factors of production. And sophisticated services as well as manufactured goods, they are intensive in capital. And this includes human capital, which is embodied in skilled workers. And then you have China and other Asian countries, which so far have had an abundance of labor, of workers, that allows those countries to produce goods that are, relatively speaking, labor intensive. So, labor intensive means that there is a certain ratio of inputs, and workers represent a large share of the input to produce that output. So here we describe the Heckscher-Ohlin model of trade. Now, in a previous chapter, which we have not studied, is the specific factors model. That was a short-run model. To briefly summarize that model, the specific factors model is a model whereby we have three factors of production: land, capital, and labor. And some of these factors of production, so this is where the name factor is coming from, some of these factors of production are non-specific, meaning they can be used in either, if you like, sector. There's two sectors in that model. So again, let's say you have two types of industries or goods being produced. So two industries, two sectors, two commodities, two goods being produced. And when we talk about a factor being specific, we talk about effect of production, for example, workers or machines, being specific to one industry or another. So to elaborate this specific factor model a little bit more, we can talk about it being a industry-specific factor model of international trade. So in those models, specific factor models, we would assume that we have these three factors of production, and two factors of production are specific to a sector or industry. So you would have land, labor, and capital. And the specific factor for sector one would be capital, and the specific factor for the second sector would be land. And the non-specific factor would be labor, would be workers. So to just show you briefly, so you have sector one, you have sector two, and the first sector is capital heavy or capital intensive, and that factor is so involved in the production of the good in sector one that that factor of production cannot easily move between sector one to sector two. Then you have sector two, and there land is heavily used. So think about the first sector as, for example, manufacturing. And the second factor, the second sector being, for example, agriculture. Now you have a final third factor. So these factors here I've described are specific factors. Land is specific to agriculture sector, and capital is specific to the manufacturing sector. In addition, you have a non-specific factor, which is labor, workers. So in addition, you have, let me use labor. And labor can move freely between sector one and sector two. So that is the way in which the bullet point here refers to the specific factors model being a short-run model, because we assume that the factors that are specific to a sector cannot move around, that the machines in the manufacturing sector cannot move to the agriculture sector, or that land that is used in agriculture cannot be refitted easily to be used in manufacturing. So in that sense, it is a short-run model because we assume that in the medium or long run, so if you like, if we allow the time horizon to expand, that over time, naturally, it should be the case that the resources used in the manufacturing sector and the agriculture sector should be able to be uprooted and be used in other industries. So in that sense, the specific factors model is a short-run model. So if you would like to know more about that model, you should consult the chapter 3 entitled Specific Factors Model. So now we move on to the Heckscher-Ohle model. So in the Heckscher-Ohle model, this is a long-run model. So a long-run model here means the Heckscher-Ohle model is a long-run model in the sense that all factors of production can move between the industries. So in the specific factors model, we only have one factor, labor, moving between one sector and the other. In the Heckscher-Ohle model, all factors of production can move around. And so in that sense, you can think of the Heckscher-Ohle model as a long-run model because we allow these time horizons that we are using when analyzing the economic situation to be of very long duration. So in the course of many decades, it will be possible for the resources used in one part of the economy, one sector of the economy, one industry, to be used over time in another. Of course, in the short run, this is not possible because of certain institutional, psychological, economic reasons that mean that certain factors are stuck more or less in one sector compared with the other. So in this chapter, we are then also examining the empirical evidence of the HO model, the Heckscher-Ohle model. We would allow for two factors of production and then also allow countries to differ in their technologies as in the Ricardian model. So first, it is important to keep in mind, we allow two factors of production and the supply of these resources, these factors of production, will be different between the two countries, but their productivity, their technology will be the same across the two countries. And then later in this chapter, in this topic, we allow the countries also to differ in their technology. But for the time being, we first, if you like, analyze only how the supply of resources will affect trade. And then later we also allow technology to be different across countries. And once we allow, if you like, technologies to differ, the predictions from the HO model match much more closely the trade patterns in the world economy today. So in other words, once we introduce some aspects of the Ricardian model into the Heckscher-Ohle model, the empirical match or the empirical support from the data for the adjusted or extended HO model is much more satisfying. Then the final goal of this chapter is to examine welfare. So we go from positive economics to normative economics, and we look at how opening up of trade will affect the payments to labor and capital in each of them. So in the HO model, in the most basic case, we assume that there's two factors of production, labor and capital, and we will examine how labor and capital will benefit or lose, respectively, once you open up a country to the rest of the world, competition from the rest of the world in terms of imports and exports. So the first assumption of the Heckscher-Ohlin model is that there's two factors of production, and these are labor and capital. And secondly, they can move freely between the two industries. They can be allocated freely without any cost between the two industries. The second assumption is that there's factor intensity. So factor intensity means that a sector, a industry or good uses one factor of production more intensively than the other industry. So here an example is shoes. The production of shoes is labor intensive because it requires more labor per unit of capital to produce shoes than it requires labor per unit of capital to produce computers. So shoes are labor intensive, and this concept of factor intensity is always relative. So when we talk about factor intensity, so factor here refers to factor of production, factor intensity that intensity is always relative, comparing one, for example, good with another. So when we look at the labor intensity in each industry, there's shoes and computers. Shoe production is more labor intensive than the production of computers. So this implies that the ratio of labor to capital in shoe production is higher than the ratio of labor to capital in the computer industry. So this is the labor per unit of capital amount is higher in shoe production. Now, we can represent this graphically. Here we have in figure 4.1 the wage to rental ratio and the labor to capital ratio in each industry. And for a given wage to rental ratio, we can ask what the demand is, the relative demand for labor in each industry. So we have the industry of shoes and the industry of computers. And for given wage to rental ratio, so this wage is the cost of the first factor, that is workers, and rent, the rental rate, is the cost of computers, that is capital. The relative demand for labor in shoes will be higher compared with the relative demand for labor in computers. So another way to understand this is what these relative demand curves for labor in each sector imply for the labor to capital ratio. So for example, in this point, for the labor to capital ratio in the computer sector, we have, for example, let that be 5, for instance. So 5 here represents, for instance, 5 units of labor, so 5 workers for every machine. And if we look at the shoe sector, so we can call the computer sector the PC sector, and the shoe sector, we can let that be, for example, 10 or 15. So let that be, for example, 15. So in the shoe sector, at that wage that we have picked, the number of workers for every machine is 15. So you can imagine that the number of people working relative to the number of machines is 15, for example, 15 to 1. So there will be more workers working with the machine in the shoe sector than in the PC sector, where the number of workers relative to machines is fewer. And this is the interpretation why the relative demand for workers in the shoe sector is higher than in the computer sector. So think about this as describing the shoe sector as being, relatively speaking, more, so relatively speaking, more labor intensive than the PC sector. So the shoe sector is relatively more labor intensive compared with the with the PC sector. So in order to have all assumptions on one slide, there's 6 assumptions in total. The first assumption is that there's 2 factors of production. And these are KL and L. And the second assumption, A2, is what we call factor intensity. That the factor intensity of the 2 goods, so factor intensity of 2 goods or 2 sectors. 2 goods, or we can also call it 2 sectors. So we have 2 factors and 2 goods, 2 factors, 2 sectors. Now, when we go to the third assumption, we have 2 countries. So we have a foreign country that is abundant in its supply of labor relative to capital. So the labor capital ratio in the foreign country exceeds that in home. So with that, we know the third assumption means that we have 2 countries and each country has a certain factor abundance, a relative factor abundance. So the Heckscher-Only model is therefore sometimes called the 2 by 2 by 2 model, because we have 2 factors, 2 goods, and two countries. So that's why the Heckscher-Ohley model is sometimes called 2 by 2 by 2 model. So the third assumption relates not just to the presence of two countries, but to the fact that we assume one country has a relative abundance of one factor over another. So again, the foreign country we denote by the asterisk. So L bar is the supply of labor in the foreign country, and K bar is the supply of capital in the foreign country. So the bar above a factor denotes the supply. That is, if you like, an upper limit, L and K. And once we attach the asterisk to it, we know that this variable refers to the foreign country. So here we have noted that L bar asterisk divided by K bar asterisk, that ratio is higher than L divided by K bar respectively at home. So this is the foreign country. And on the right-hand side, we have the home country. The flip side of one country being labor abundant, foreign country being labor abundant, the flip side of that is that home is capital abundant. So what we can do is we can express the ratio of the two factors also by letting K be in the numerator, that is on top, and L in the denominator. So that the capital to labor ratio at home is higher than the capital to labor ratio abroad. So this abundance, this factor abundance, is always a relative concept. So take, for example, figures that will illustrate what we mean by factor abundance. So for instance, take home and abroad to have the following number of workers and capital. So assume that, for example, at home, so home I denote by H, there is 500 numbers of workers at home, and capital is equal to 500. So then if you take L divided by K, that equals a ratio of 1. For home. Now, if you do the same calculation for H, let's assume then the foreign country, F, has labor 1,400 and capital 100. Then 1,400 divided by 100 is 14. So this number here would be 14. Because 1,400 for L divided by K being equal to 100 is 14. 1,400 divided by 100 is 14. And on the right-hand side, 500 divided by 500 is 1. So think of this as the foreign country, for example, being China, where there is a vast number of people living in China. And absolutely speaking, if we compare the number of people, workers in the foreign country, they are higher than the number of people at home. But what matters here is the ratio of workers to capital. So think of this number 14 and 1 is that the labor to capital ratio is how many workers there are for every machine. So how many machines is each worker working with? In the home country, each worker is operating one machine. So think of this as a worker who is maybe highly skilled and he's working with a machine that fully occupies all of his skills. And then in the foreign country, there's perhaps 14 workers working together with one machine. It does not necessarily mean that all of these workers are working using that one machine. So, for example, it could be that 12 of the workers are working without a machine, and then only the remaining two are working with another machine. But in total, if you compare the ratio of workers to the amount of machinery available is much higher in the foreign country, and therefore it is abundant, relatively speaking, abundant in the supply of labor relative to capital when we compare it with the home country. So now moving on to the other assumptions. The other assumptions are a little bit more straightforward. Assumption 4 is the final output, shoes and computers, can be traded freely. So there's no trade restrictions between nations. And labor and capital, however, cannot move between countries. So we do not allow for any migration, international migration of labor, nor the shipping of, for example, the machinery. So here you should think of capital as physical capital rather than financial capital. So we assume that there's no trade restrictions and the factors of production are not movable between countries. Then assumption 5 is the technologies used to produce the two goods are identical across countries. So this is an important assumption here, which can be relaxed later. In the Ricardian model, we assume that the technologies to produce the two goods are not identical across the two countries. And that is, if you want to refer back to chapter 2, is denoted by the production function being of a different functional form in the two countries. And that is shown once we, if you like, take the derivative of the production function with respect to the factor of production, labor, then we have a different level of marginal product of labor. And the difference in MPL, marginal product of labor, is suggestive that there is different technologies in the Ricardian model. In the Heckscher-Ohlin model, we assume that the production functions, the mathematical form, is the same. In other words, economically, it means that the technologies are the same. So the technology here just means how does input, production input, translate into production output. So if the two countries have the same amount of inputs, they will produce the same amount of outputs. So this is under the Heckscher-Ohlin model. Under the Ricardian model, we assume that even for the same given amount of inputs, the two countries have a different output that is due to their comparative advantage, that again in turn is due to their technological differences. So finally, assumption 6 is that the tastes for consumers are the same across countries, and the consumer preferences, that is their dislike and like, and the utility for computers and shoes, do not vary with the country's level of income. So in other words, what we assume here in these two assumptions is that the two countries are identical in terms of their consumer household preferences and their technology. The only way in which the two countries in the basic Heckscher-Only model differ is their factor abundance. That is the only difference between the two countries in the Heckscher and Only model. The relative factor abundance, which is due to the different supply of the two factors and their ratio between the two. But other than that, the two countries do not differ in their production technologies of the two goods that they are producing. In the simple Heckscher-Only model, we assume that we have countries that have the same technology. So the sectors, the two sectors, however, have different factor intensities. That means one sector is using labor more intensively than the other. Now, there is a concept called reversal of factor intensity or factor intensity reversal, which is suggesting that once you have a change in the wage to rental rate, that actually a previously labor intensive industry could become a capital intensive industry. So in other words, in the simple Heckscher-Only model, we assume that irrespective of the wage to rental ratio, so irrespective of how much wages divided by rental, if you like, the rental cost of capital is, the industry of one exceeds that of the other industry, disregarding what the price is of the factor input of one factor input relative to another. So this is a, if you like, a complex topic, and it will make for very interesting extensions to the simple Heckscher-Only model. But something to just keep in mind that this is an extension that we do not cover in the simple model. So now here we look at the PPF, Production Possibility Frontier, and this is figure 4.2. So on the left-hand side, you have the PPF for the country at home, and on the right-hand side, the PPF for the foreign country. And you can see that we have two countries, and then second, two sectors, shoes and computers in both countries. Then second, you notice that the production possibility frontier compared to the simple Ricardian model now is no longer a straight line with a, if you like, constant slope. It's not a linear function anymore, but rather it is concave, bent towards the origin. So the home production possibility frontier shows the output mix that is technologically feasible. So the country again can choose to, for example, produce only shoes and specialize only in shoes, or it can produce only computers, or produce an intermediate output mix, for example here, or here, or here. Of course, the country can also produce on the inside of the PPF, but that would not be making use of its factors of production, its supply of resources fully. Therefore, it would not be optimal. If you trace this level here of dedicating all resources at home towards shoe production and compare that to the level of output that the foreign country can produce if it were to produce shoes only, you have to keep in mind that the technology, so the productivity of the, if you like, industry in the foreign country and the home country is the same. So the technology is the same. However, what makes this production possibility frontier different is that the supply of the factors of the resources are different. So if the foreign country dedicates all of its resources, that is capital labor, to shoe production, it can produce more shoes than the home country. Similarly, you can do the same comparison if the foreign country produces only computers and you trace it to the other side. That will be roughly here, and you can see that the home country could produce more computers if it were to dedicate and specialize itself in the production of computers only. And this difference in the capacity of production is not due to how differently productive the country is at home relative to abroad, but it is due to how much resources it has available, how much capital and labor it has available. So home is capital abundant and computers are capital intensive. The production function describing how inputs are related to the output of computers suggests that the optimal ratio of capital to labor, that is of machines to workers or vice versa, of workers to machines, is higher, is more skewed towards use of capital in the computer sector. Therefore, it suggests that due to the relative abundance of capital relative to labor in the home country compared with the foreign country, it would suggest that the capital intensive good can be produced at a higher quantity, given that home is capital abundant relative to the foreign country. Therefore, the PPF of home is more skewed towards the capital intensive good. Now, be aware how I've phrased and be careful with the use of capital abundant and capital intensive. Capital intensive refers to the production technology, the sector, the industry. Abundance refers to a country, not the sector. It refers to the country and its supply of capital and labor relative to the foreign country. Because factor abundance is a relative concept, it could be the case that a country is capital abundant, although that country has less total or absolute amount of capital relative to the foreign country. So it could mean that although a country has, when we just count the number of machines, has fewer number of machines compared with a foreign country, but because it has more machines relative to the number of workers, when we compare that ratio, the K to L ratio, to the K to L ratio in the foreign country, a country can be relatively capital abundant, although overall the absolute amount of capital is less than the other country. So this is something to keep in mind when we talk about capital abundance. And here in this case, it seems likely that the home country is not just capital abundant in the relative sense that it has more capital to labor, if you like, as a ratio compared with foreign, but it probably also has a higher amount of capital overall relative to the foreign country. So just comparing K at home to K at foreign does not necessarily give us an indication about the country being capital abundant. When we talk about capital abundance is when we compare the K to L ratio to the foreign K to L ratio. We do not compare K at home to K foreign or L home to L foreign to talk about whether or not a country, for example, China, is labor abundant or capital abundant. So it might be the case that, for example, China has a lot of people because the population is large. But if, for example, in the future, the amount of capital machinery rises exorbitantly, and it could lead to the result that China could be a capital abundant country compared with another country, although the number of workers, the number of, if you like, the stock of labor in China would be higher than in a comparable country. So that is something to keep in mind, that the factor abundance, capital abundance, labor abundance, is a relative concept. It is relating to the ratio of K to L, or if you like, vice versa, of L to K. That is what we are comparing, and that is to be kept in mind. So if you consider the PPF to represent supply, the supply of the home country, the indifference curve depicted here with U is representing demand. It suggests that at all these different levels on the indifference curve, the utility is the same. So if we pick, for example, an indifference curve that would be lower, we would not be reaching maximal utility, because utility at, for example, here, B, could be improved by getting a higher amount of shoes without sacrificing any computers. So in that sense, U is feasible and it is yielding the highest level of utility. This indifference curve here is not feasible because we are not able to produce, for example, more than maximally this amount of shoes for the given supply of capital labor at home. So where the indifference curve touches or is tangential to the PPF, at this point we have the highest level of utility. The slope of the indifference curve so the slope of the indifference curve is equal to the amount that consumers are willing to pay for computers measured in terms of shoes. So what we are comparing here is the amount that consumers are willing to pay for computers, the good on the horizontal axis, in terms of shoes to keep utility constant. Why is this the case? So if we reduce the amount of shoes from this level to this level, of course, there will be a change in utility due to the decline in the quantities of shoes consumed. So when we ask how much does the consumer need to be compensated by in terms of the increase in computers to yield a equivalent increase in utility, we can say that the slope of an indifference curve therefore is suggestive of the quantity of consumers, the quantity that consumers are willing to pay for computers measured in terms of shoes, so to keep the consumer on the same indifference curve, yielding him or her the same level of utility. So recall that the slope of the PPF, or the PPF, is the opportunity cost of the good that is on the horizontal axis. So here it would be the opportunity cost of computers in terms of the amount of shoes that has to be given up to obtain one more unit of computers. So the opportunity cost of computers is how much do we need to give up of the other good? So how much do we need to give up in terms of shoes? So how much do we need to give up in terms of shoes in order to gain another unit of computers? Okay. And then the slope of the indifference curve is the relative price of computers, or whatever is on the x-axis, and the relative price of computers therefore is also referring to the price in terms of the good that is on the y-axis, that is the vertical axis, here shoes. Now we're moving on to the foreign country, and the indifference curve there, it should be noted, has the same shape. So the indifference curve, if we would draw it, such as this, it would have the same shape as the indifference curve at home. So what I mean by that is the indifference curve in the foreign country is not looking, for example, like that, being tilted towards the right or tilted towards the top. So it's neither tilted towards the top or tilted towards the right, but it looks as it does on the slide. So this is very important because it relates to the assumption that consumer tastes are the same, assumption 6 across countries. And in addition, we also assume the preferences for if you like, of the consumer for computers and shoes do not vary with the level of income of a country. So this means that it doesn't matter if we consume more or less, or if we get richer or poorer. The preferences for the specific type of combination, how much we need to be compensated for by reducing one good in terms of increasing the other good, stays the same. In the shape of the indifference curve will be therefore similar, regardless of how far out we shift the indifference curve. So a difference curve will always look something like that, instead of tilting to the left or to the right, depending on the level of the utility obtained. So this is very important. However, then also note that this, although the indifference curve has the same shape, the point at which it is tangential to the PPF, that slope at that point will be different, because the PPF in the foreign country is different. The PPF in the foreign country is different due to the different supply of capital labor in the foreign country. So the production capability, the output ability of each country depends on its supply of capital labor. And this is not to do with how productive it can be due to the technological differences, but only due to resource differences. Now, if you take any curve, let me draw one here that looks a little bit like the indifference curve. The tangent here and here and here at this point, and this point suggests a different slope at these different points. So naturally, if we take the slope where there's a tangent in the home country and we apply that to the foreign country, we see that at this point here, the slope at home and abroad is not the same. Okay, so if you read the blue shaped box, what this means, you can see that it says the foreign country is labor abundant and shoes are labor intensive. So the shoes production function prefers a higher labor to capital ratio than does the computer production function. Therefore, the foreign production possibility frontier is skewed towards shoes. The foreign preferences are summarized by the indifference curve U star, and foreign no trade equilibrium is at point A star, with a higher relative price of computers as indicated by the steeper slope of the price line. So the price line is the result of where the indifference curve is touching the PPF. So depending on demand is representing the preferences of the consumer, and demand is here represented in the indifference curve. depending on where demand meets supply, due to the different shape of the PPF at the home and at foreign, there is therefore an effect on the relative price of computers relative to shoes. So therefore, it suggests that the relative price of the one good over another is different at home and foreign when the economy is closed, and that is due to the supply of the resources in terms of capital and labor supply, that will make one good more expensive than another, relatively speaking. So in the foreign country where there is an abundance of labor, relatively speaking, the good that is capital intensive, that is computers, will be relatively more expensive compared with the home country where there is capital abundance. And in the more capital abundant country that is at home, the price, the resultant price in equilibrium, in the no trade equilibrium, means that the relative price of computers, which are capital abundant, will be cheaper. So therefore, to put it succinctly, in the capital abundant country, home, the capital intensive good will be relatively cheaper. The relative price of the capital intensive good will be cheaper. In the foreign country, it will be the opposite. The capital intensive good will be relatively expensive. Vice versa, if you flip, so what you could do is you can flip shoes and computers, and instead of shoes being on the y-axis, you can let computers be on the y-axis and vice versa. You can do the same thing for the relative price of shoes and then see that the labor intensive good is relatively cheaper in the foreign country, or that country which is labor abundant. So recall that point A is the no trade equilibrium. Now, when we open up to trade to the rest of the world, the world price line, that is the relative price of computers relative to shoes, is depicted as PC divided by PSW, and that is the red line here. If this price line is steeper than the previously relatively more flat no trade price line, the internal economy, the closed economy's price line, once the slope is relatively steeper, you can see that there will be a change from A to B. So it says that home produces at point B. It goes from producing at A to producing at B. And then it can consume at point A, upon point C. So initially, point A represents production and consumption. Now, after trade, similar to the Ricardian model, the production point does no longer need to represent the consumption point, because what is produced does not need to be all consumed, because some of it can be exported. It suggests here there is an export of computers. So at B, home produces, but it consumes less because it is consuming at sea, and that amount is exported, and it imports shoes by this amount. Although it produces only this amount, it actually consumes QS3, and this is the amount of imports. The trade triangle that is, if you like, shaped and colored in green has a base that is equal to home exports of computers. And the difference between the amount produced and the amount consumed with trade is QC2 minus QC3. And this is, if you like, the so-called trade triangle with a base equal to exports. The height of the triangle is home imports of shoes. Now we can represent this as a supply curve. So if we take the autonomy or the autarky price line, that slope is PCPSA. And then when we take this line, that is PC divided by PSW, and that is this point here. And at that point, the amount of computers that are exported by the home country is QC2 minus QC3. This amount is equal to this amount. Of course, it is not drawn to scale, and you can draw it to scale if you wish to, but it is not necessary in this case. So what you get from this diagram is that if there is a rise in the relative price of computers which are exported by home, because home is relatively speaking abundant in capital, and computers is a capital intensive good. That is, the computer industry is a sector that produces a output whose production process uses capital, relatively speaking, intensively when compared with another industry which uses a lower capital to labor ratio for outputs. So if you have an increase in the relative price of computers, naturally, as a supply curve, the supply curve should slope upwards. There should be an increase in supply. If you have an increase in the price of the good produced, there should be an increase in the quantity, and therefore the supply curve should slope upwards. This is supply curve in terms of exports of those computers. Similarly, for the foreign country initially produces at A star, A asterisk, and then foreign produces at point B subsequently, once it opens up to world trade, and it produces there, but it can consume there. So although it produces this much and it consumes this much, it means this amount is exported. And although it produces this much, but it actually consumes this amount, this, if you like, this total amount, the difference is imported. And the trade triangle has a base equal to foreign imports of computers. And the side is equal to shoe exports. And now we do the same thing as we did with the home country in terms of the panel B. So now we trace the foreign demand for computers. So we just look at the flip side in the market for computers. First, we take the no trade autarky price, relative price, and this price has a relatively steep slope, and that means if you like, the relative price of computers is high, and that is depicted at this point here. And at that point, the quantity of computers demanded is 0. Now, when the world price line is such that the relative price of computers is lower at PSW, so this would be this line in red. At this line in red, the amount of imports is equal to QC3 minus QC2, which is equal to this. So although the country is producing at B star, this is B star here, foreign production, it is consuming at C, and that difference is the amount of imports. So what does this mean intuitively? When the price of the good falls, there's an increase in demand, and demand is sloping downwards, which makes intuitive sense. So at the point where the supply of exports equals the demand for imports, there is an equilibrium, and there is no reason for the relative price to deviate. So in that sense, at point D, there's an equilibrium. The quantity of computers supplied and the quantity of computers demanded is the same, and therefore the relative price has reached an equilibrium at a quantity where demand and supply are equal. So to summarize, the Heckscher-Ohlin model has the result that trade patterns are determined by the abundance of a factor. So a country is exporting that good whose supply of a factor it is abundant in. In other words, if computers is a capital intensive good and a country is relatively abundant in that good compared with the other country, that country who is abundant in that sector, who uses that factor intensively, will export that good. Home is abundant in capital. Computers are using capital intensively. Therefore, home is producing computers which it's exporting to the rest of the world. Vice versa, foreign. Foreign is abundant in labor. Shoes is a sector that uses labor relatively intensively. Okay, be careful here not to mix up abundant and intensive. Abundant is linked to factor supply, and intensive relates to a sector's use, optimal use of a factor. So foreign is abundant in labor, and therefore it produces the labor intensive good, shoes, and exports that to the rest of the world. And this is the HO theorem. So HO theorem is just the main idea of the HO model. So the main difference here is, whereas Ricardo suggested, well, two countries are different in their productivity of producing different goods. One is better at producing that good in that sector, and another country is better, that is more efficient in producing that other good in a different sector. Heckscher and Olin, they have a model which suggests that even if the two countries, or if you like, the two entities, even if you and I are equally productive or effective, we start out with the same type of technology. But if one of us has a different ratio of endowments of resources, of factors of production, that endowment, although we start with the same technology, although we start, if you like, with the same knowledge, with the same access to the, if you like, science and the way to translate inputs to outputs, our exports and imports will be, if you like, shaped by how much we are endowed with by, if you like, nature and natural resources, such as capital and labor. And some of these resources, of course, are not natural because they're being produced and are endowed with by prior generations. So the main ideas of the Heckscher-Olin theorem is a country will export that good whose supply it has abundance in when that good is using that factor intensively. So another way to think about this is that indirectly the country that is abundant in a factor is indirectly exporting that factor, although that factor cannot move, that resource cannot move, we assume, but in terms of it cannot move internationally. So the machines are stuck at home, and these machines are so large that they cannot be physically moved to another country. But the that, if you like, resource can be embodied in the good that is being produced, and that good that is using that factor intensively therefore embodies that resource, and indirectly that resource embodied in the good is being exported to the other country. This is another view of looking at the Heckscher-Olin result. So again, recap, what are the assumptions? We assume that the resources are flowing freely between the two industries inside the country, not between two countries. So this is between the two industries in the same country. That's important to note. And then the productions of shoes is labor intensive, and the other good is capital intensive. And so this here is a assumption about factor intensity. Then we have a question about factor abundance, where one country is abundant in one factor versus another. Then we have free trade international goods, no barriers to trade. And then we also assume that there's same technology for producing shoes. So that means the production function for shoes is the same in both countries. And the production function for computers is also the same in both countries. And the consumer tastes are the same in both countries. So those are the assumptions that feed into the Heckscher all-in theorem. Of course, you can relax those assumptions and see what happens to the Heckscher all-in result. Wassily Leontief in 53 took the HO idea to the data. He supposed that US is abundant in capital relative to the rest of the world. And he suggested that the US and foreign technologies are essentially the same due to limited data on foreign technology. And this assumption is similar to the HO model. So, based on this, the expectation and the hypothesis coming out from the model is that the United States, because it is capital abundant, would export capital intensive goods. However, Leontief, in his data digging and data study, found that the capital labor ratio for US imports is actually higher than the capital labor ratio found for US exports. In other words, it seems that the US exports are capital, so the US imports are capital intensive and US exports are labor intensive compared with the US imports. So this kind of seeming contradiction is called a paradox, and this is named after Leontief. So Leontief paradox is basically saying that the central prediction of the HO theorem that a country who is abundant in a factor will therefore export that good that uses that factor intensively is not observed in the data that Leontief studied. Now, be aware that these data, the data range is limited, and he didn't study it for all countries. He looked at the United States for a specific period, but he found that the central prediction seems to not be confirmed in the data. Namely, that although the United States, he thinks, is abundant in capital, it seems that the nature of exported goods seem to suggest that the exports are labor intensive compared with the imports to the United States. So this is the Leontief paradox. It's basically a challenge to the model and the prediction of the Heckscher all-in model. So how did Leontief arrive at his conclusion and his finding? So he used the following numbers. So the column shows the amount of capital labor needed to produce $1 million worth of exports from the United States or imports, respectively. And you can see in the first row that the amount of capital in million US dollars is 2.5 in the Xbox sector, and labor, if you like, person per years is 182. And if you divide that and express it as the amount of capital, for example, machinery needed, measured in dollar per person, it would amount to $14,000 worth of capital per worker. And then if you analyze imports, you have 3.1 and 170 as the respective number for capital and labor, and then the ratio of the two would be that it requires 18,200 US dollars worth of machinery per person for producing $1 million worth of imports. So by this comparison, it seems to be the case that exports are less capital intensive than imports, which is contradictory to the HO theorem, which suggests that actually, if the United States is a capital abundant country, it should export goods that use the abundant factor intensively. It should export capital intensive goods rather than export seemingly labor intensive goods, relatively speaking, compared with imports. So there are several explanations for combining the paradox with the HO theory to suggest that the HO theory cannot be so easily debunked by the Leontief paradox, because the parameters of the study do not fully and necessarily usefully represent faithfully the assumptions under which the central results of the HO theorem have been derived. So what does this mean? This means that the technologies in the theory are assumed to be identical between home and foreign. But in reality, the US and foreign technologies are not the same. So that assumption does not hold in the data. Therefore, by that assumption, there should already be an adjustment that will result in a different result, or would lead to a different result. Secondly, by focusing on labor and capital, Leontief ignored land abundance in the United States. Third, Leontief didn't distinguish between skilled and unskilled labor. The simple HO theory also doesn't do it, but it should be, if you like, taken into consideration that US exports are intensive in skilled labor. So that is where human capital is very high of those workers. And human capital is relatively abundant in the United States compared with its trading partners in the rest of the world. And then there's another point about data range, that 47 might have been a rather particular year because of political and economic and military upheavals related to the Second World War that just concluded 2 years earlier. And finally, the free trade assumption and no barriers to trade are also not given in reality, because during that time, barriers to trade were quite high. So there is a lot of assumptions of the HO theory that did not really apply, and the deviation from the assumptions is quite significant, which would suggest that the paradox, the contradictory finding Leontief found in the data, does not really directly challenge the HO theorem once we adjust those empirical phenomena in the model. So in the following, we will look at some data relating to the actual fact endowments of different countries. And what we will find is the following. We'll find that actually the results of Leontief did not directly overthrow the HO model and the HO theorem, but rather complement and further extend it. Because what we will find in the next slides is that once we adjust the supply of labor by its effectiveness, we can see that the United States is actually abundant, not just in capital, but also in labor. So previously, we just looked at capital and labor simply, but once you adjust labor for the productivity of labor by using the wage rate, you can find that the United States is relatively abundant in both labor and capital, and therefore it should be also found that its exports should be intensively using capital and labor. That is something we will find in the next few slides. So in order to determine whether a country is abundant in a factor, the country's share of that factor will be compared with its share of world GDP. So if that is exceeding the share of world GDP, then we can talk about the country being abundant in that factor. And if it is less than its share of world GDP, then we can talk about the country being relatively scarce in that factor. And we proceed now to look at the data. So these are country factor endowments. Let's start with column 7. In column 7, we can see world GDP, and this sums to 100%. We can ask how world GDP, that is measuring gross domestic product in terms of economic activity during the year 2013, where that economic activity and output is taking place. You can see that the top part of column 7 is 16, so that 16.5% of the, if you like, the cake, the value of economic output in that year is produced by the United States. China produced 16% of output, so that is just trailing the United States. And then there's a host of other countries. Now, columns 1 to 6 represent different factors, and the factors, if you add them all up to each other, should also equal 100%. So if you, for example, look at arable land, the United States has 11.5% of all arable land available during 2013, and that is less than its share of economic activity. So if it is underweighted, if you like. Similarly, with less skilled labor and physical capital, as well as illiterate labor. For all of these, their share is less than 16.5%, which is the GDP share of the United States. So to, if you like, mark down the relative abundance of different factors, we can see that the United States has a relative abundance in R&D, research and development scientists, in skilled labor, which is relating to human capital as well as skilled labor, that is human capital augmented labor. Now, if we look at China, China has a GDP share of 16%. So 16% of all economic output during that year is done by China. And you can see that it is underweighted in terms of illiterate labor and arable land, as well as skilled labor, and it relatively is abundant in physical capital, in R&D scientists, as well as less skilled labor. So illiterate labor is labor that is illiterate, unable to read or write, where India is quite holding a significant share. So that suggests that the United States is relatively scarce in arable land, and however, although it is relatively scarce in arable land, that is kind of misleading because we do not take into account the productivities of the different factors. And that is what we will do in the following slides. So once we adjust the factor for effectivity, we will have an adjustment of each factor. So for example, labor force times its productivity will increase the amount of labor force when it's adjusted by its effectiveness. So instead of just counting, this is a general point in terms of the quantity of people, we need to adjust it by the quality. And that is not so easy to do, but this is what we will attempt in the following slides. So we take the factor endowment and multiply it by its productivity to obtain the effective factor endowment. So in order to check whether or not there is abundance or scarcity of effective factor supply, we take that share of the effective factor and look at its share of world GDP. For instance, we take the actual number of R&D scientists, recent development scientists, and multiply it by the spending per scientist because that is augmenting the effective scientist. So you can think of this as if you have 100 scientists in one country and 100 scientists in another country, if the scientists in the first country have double or triple the amount of spending available to them to function and carry out their research, probably the effective supply of those scientists, that resource will be higher compared with those scientists who have much, much less resources available, which would reduce their effectivity. So here in column 5, again, we have the world GDP and the share for each country, and the figures are, of course, unchanged. The United States still has 16.5% and China 16%. And now if we look at the effective scientists, if you compare column 1 and 2 with each other, we can see that there is a very clear abundance of effective scientists, these, if you like, the supply of that resource in the United States. And at the same time, you can see that although China was overweight, if you like, it had a relative abundance of scientists, but the spending, the available resources that they have, mean that the share 20.3% shrinks to 8.1%, and that shrinks because the share by United States and by other countries has increased. So for example, the the United States shares increase because it has relatively more spending per scientist, and the same is the case in Japan, where Japanese scientists also have more spending available to them. And the same thing occurs in both Germany, where its share goes from 5.1% to 7.7%. And when we move to land, the United States was relatively scarce in its availability of land, but once you adjust it for its effectiveness, then it has nearly doubled its share of GDP, of its share of world effective arable land, that is, goes from 11.5% to 20.7%. So its shares increases, and for China, that share is falling from 7.8% to 3.9%. So once you adjust the factor for its effectiveness, you can actually have quite dramatic reversals of whether or not a country is abundant or scarce in a particular resource. So for quite some time, China has dedicated a lot of resources to attracting the best of the best from other countries in order to help the development of China and its infrastructure as well as its research base. And this includes so called Haigui, that is, returnees, Chinese, ethnic Chinese who have gone abroad to study and then return to their home country. And this has extended recently also to more efforts being spent to attract and recruit the talents from abroad that are not Chinese but are foreigners. And this slide mentions something from the news where people from Silicon Valley also are increasingly flocking to China, partly being attracted by the favorable conditions to conduct high quality research in China, given its availability of highly skilled engineers. So, Table 4.2 shows US food trade and US agriculture trade, exports, imports, and the difference between them, that is net exports. And you can see that for food trade, there are some years where net exports are negative, which means that imports are higher than exports. So the United States in some years is a net importer of food. At the same time, when you look at agricultural trade, that includes, for example, things like cotton, which is not necessarily food, it consistently has positive net exports. So this is in line with the, if you like, conclusion that the United States is actually relatively abundant in land. And if it is abundant in land and agriculture is a sector that uses that factor land intensively, we should see the US also being a net exporter of that good that uses that factor intensively. So this is confirming the result that once we adjust the factor endowments by its effective, if you like, scalar, then the Heckscher and Oli models central prediction that the country will export goods that are intensively using the factor that it is abundant in holds true in the data once we make the adjustment for effectiveness of the availability of the resources. So this is some further confirmation about the labor abundance in the United States, that although it has relatively little labor as its share of world population relative to its economic output, but that is 8% relative to 37%. But once we adjust it for the effectiveness, um, and effectiveness should be related to productivity. And if you recall, this is harking back to that the wages should be in some shape or form be related to productivity. If you recall that point being mentioned in the David Ricardo's model in chapter 2, then you see that the share of the United States of effective labor is quite high. Obviously, wages being high is not a perfect measure of the effectiveness of labor, because the fact that the effective labor of the United States represents 43% is quite a staggering figure. There are other factors that also explain the amount of wages being so high relative to the rest of the world, as we will learn in the rest of the course. But certainly the figure should be higher than a mere 8% to reflect that effective labor intensive goods can also be exported by the United States because it has a relative abundance in that factor. And this is something that is relating to the previous slide, relating the wage, relative wage, to productivity. So here, these are estimates of productivity of workers across countries and their wages compared with the US in 1990, and they are highly correlated. And the black line is the 45-degree line. So it is not the case necessarily that for each and every country there is a one-to-one correspondence, but it tends to be a positive correlation between productivity and wages. So this suggests that the wages which are high in the United States, that they are indicative of productivity, and vice versa. Uh, more productive workers will be paid a higher wage. And this is, of course, the case in general as a tendency, not perhaps in each and every particular instance. The economy-wide relative demand for labor will probably be between the relative demand for labor from the shoe sector and the labor demand for the from the PC sector. And at the equilibrium point A, that is where the relative supply L bar divided by K bar is intersecting the relative demand. So when supply for labor intersects demand, we have the equilibrium wage to rental rate. And this is the determination of where the wage to rental rate will be at home. So the effect of trade on wages and rental income is as follows. So there is an increase in the price of computers. You can see that at home, at the no trade equilibrium at point A, the relative price computers is PC divided by PS A for autarky. And once there is a opening up to the rest of the world, the slope actually becomes steeper. So this is akin to a rise in the relative price of computers relative to shoes. So this increase shifts the production from point A to point B, where the amount of computers being produced increases from C1 to C2. And at point B, there's a higher output of computers and a lower output of shoes. The increase in the relative price of computers then therefore also shifts the economy-wide relative demand for labor. So not just the price is affected, but also the relative demand for labor. And that is shifted from RD1 towards RD2. And the effect on the wage is the wage to rental ratio is that there is a fall. While the supply of labor to capital is fixed, the ratio of wage to rate of return on capital falls as there is a increase in the relative price of the capital intensive good. There is also therefore a fall in the relative price of the good of the resource of the factor which that industry is using less intensively. So as the relative wage is falling, the wage to the rental rate, we know that before the change, the intersection of the relative wage rate to the relative demand curve is such that L to K 1 and L to K 1 in terms of the shoe sector and the computer sector is then raised once the wage falls. So when the factor labor becomes cheaper, there will be more used of the factor, relatively speaking. That is natural. So the cheaper a factor becomes, the more it will be used. And the reason for why it is possible for the L to K ratio to rise in both industries, although the amount of resources remains fixed at L bar divided by K bar, that is because as the quantity of PCs produced rises, the quantity of shoes produced falls, and we know that shoe production is labor intensive. So as there's a reduction in the production of shoes, there will be quite a lot of labor released because shoes are a labor intensive good. So more labor per unit of capital is released from the shoe sector than is actually needed to operate that capital in the computer sector. So we know that the PC sector will increase its output and the shoe sector will decrease its output because the relative price of PCs has risen. But because there's so much labor released from the labor intensive sector, and not all of that labor does need to go to the capital intensive sector, that is computers. So some of it can also go to the shoe sector. And therefore, that shoe sector will also exhibit a rise in the amount of workers per machine. So the LK ratio will also rise in the shoe sector. So to summarize, we know that the rise in the relative price of computers that are capital intensive will lead to a decline in the relative wage, W divided by R. And this in turn leads to an increase in the LK ratio in each industry. So although we know that the relative wage falls, in order to determine who is actually getting a welfare gain and a welfare loss from these changes, we need to not just look at the relative wage rate, but actually the purchasing power. That means the translation of the wage into the real wage and the translation of the rental rate into the real rental rate. That means the change in the quantity of shoes and computers each factor of production can purchase after the change. And this is what we will do next here on this slide and the following. Recall from the firm profit maximization problem that the first order condition for a firm in its labor choice is the wage rate divided by price, and that should be equal to the marginal product of labor. So this is what we derived in chapter 2. Now, when we talk about another factor that is not labor but capital, so the first order condition or the optimality condition, the first order condition for capital choice implies that the wage rate or the rental rate divided by the price should be equal to the marginal product of capital. So hopefully you can see the similarity between the two. It just suggests that the marginal cost of hiring an additional unit of capital, which is the real rental rate, should be equal to the marginal benefit of that additional unit of capital, because if the marginal cost equals the marginal benefit, then we should be at an optimal location in terms of profit maximization. It wouldn't make sense to hire capital up to a point where the marginal cost actually is exceeding the marginal benefit. Similarly, the marginal cost of an additional worker, labor, is the real wage rate, and the marginal benefit is the marginal product, that is the contribution of that additional worker to the production process, MPL, and it should be equal such that the first order condition of the, if you like, profit maximizing firm would choose labor such that W divided by P equals MPL, and it chooses K such that R divided by P equals MPK. Now, that is the theoretical background that makes you understand that these formulas are not plugged out from thin air, but rather are based on economic understanding and theory. And here we have just put PC on the right-hand side, and we have two of those formulas because we have two sectors. We have the PC sector, the computer sector, PC sector, and the shoe sector. And the real rental rate is the return for capital. And we can rewrite the formula such that MPK is on one side and R divided by PC is on the other side. So with an increase in labor that is available as the labor capital ratio, there should be more people to work with each piece of capital, and therefore it should increase the marginal product of capital. And if there's an increase in the marginal product of capital, then therefore there should also be an increase in the rental rate. So this means, to summarize, that the fact of production capital makes a gain from opening up to trade. So capital benefits from trade. Now, what about labor? What about the other sector, or if you like, the other class? So with labor, we have already explained these first order conditions, where they come from. W equals P times MPL. If we rewrite that, you can see here that MPL C equals W divided by PC, and this will fall. Because the labor to capital ratio will increase in both industries, in both PC industry and the shoe industry, due to diminishing returns to scale, the marginal contribution of each worker in each industry will be smaller. So therefore, the marginal product of labor in each sector will also fall. And recall that here in the Heckscher-Ohlin model, we have assumed diminishing returns to scale, and that is why the production possibility frontier is shaped concave, like a curve, towards one viewed from the origin. So the result on the previous slide can be summarized as the Stolper-Samuelson result. It suggests that when all factors are mobile inside the country in the long run, the rise in the price of a good will increase the real earnings of the factor used intensively in the production of that good and decrease the real earnings of the other factor. So in other words, one's home is opening up to trade, and it has then a higher relative price of computers. The real rental, the return on capital at home rises, and the real return to the wage, to labor, that is the real wage, will fall. And vice versa in foreign. So this idea is the Stolper-Samuelson result that suggests that there's clear losers and winners from trade, in a sense of one, if you like, one factor will lose, the one that is used intensively in the export will win, and the one that is used in, if you like, in the import sector will lose, and vice versa in the other country. So the specific factors model of chapter 3, which I explained very briefly at the beginning of this lecture, suggests that labor may gain or lose from trade as it is a movable, non-specific factor, but the specific factor in the export sector is gaining clearly, and the specific factor in the import sector loses clearly. So labor earns some part of the rental on the specific factor in the industry. So the industry of employment where the worker is working will determine or influence the attitude towards free trade, because they may gain or may lose depending on the rental on the specific factor in their industry that they are working in. So this is in contrast to the Heckscher and Olin prediction, which we'll look at in the following. In the Heckscher and Olin model, it is suggested that regardless of the industry where the worker is working, the relative price of exports will benefit the factor of production used intensively in exports, for example, capital, and harm the other. So, regardless of the industry in which these factors of production actually work. So, the Heckscher and Olin model suggests that if you are a worker in a country that opens up to trade, and trade is leading to the export of the capital intensive good, this will harm you because the wage will fall. Whereas if you are a worker in a country that opens up to trade, and that good that is being exported is a labor intensive good, because you're a labor abundant and you live in a labor abundant country, then that will benefit you as a worker, irrespective of whether or not you work in the uh, labor intensive industry or the capital intensive industry. So that is, if you like, a central prediction of the Heckscher and Olin model, which is slightly in contrast to the specific factors model that I mentioned on the previous slide. So if we take this point from the Heckscher and Olin model and apply it to the United States, the goods that are exported from the United States to the rest of the world tend to be intensive in highly skilled labor. That is R&D and scientific work. Includes design and things of similar nature. So when there's a relative price of exports that is rising, which would benefit that skilled labor in the long run, irrespective of whether these workers are employed in the export-oriented industries or the import-competing industries, it would suggest that if you're a worker, your attitude towards free trade, that is more specifically whether or not you gain from free trade, will be actually linked to the skill level that you have as a worker. So if the country that is exporting highly skilled labor intensive goods, and you're a worker that is highly skilled, that would suggest that you actually benefit irrespective of whether or not you work actually in the, for example, iPhone industry or design industry, which is helpful for, or chip design, chip manufacturing, which might be part of the export from the United States, at least the chip design and the development behind it. So you might benefit as a highly skilled worker if you work in the export industry. But if you are highly skilled, but you work actually in an import competing industry, you will also benefit, regardless of whether or not you work in the sector that is facing competition from imports or not. So only the skill level will determine whether or not you gain or not. It means that if you have a low level of skill, that you as the part of the, if you like, the labor class or the working class will suffer if you have little skills, because those are being eroded. The relative price of it will be eroded by opening up to trade. So this prediction that the skill level of a worker might suggest that the attitude towards trade is impacted is supported by an NES National Election Studies survey, where the industry of where you work is important in predicting how you feel about trade, but also the skill level is even more important to, if you like, predict your attitude towards trade. And of course, the export-oriented industries has workers which are more favorably disposed towards free trade than those in import competing industries. And the higher the skill level of workers, irrespective of whether or not they are import working in import or export oriented industries, is a higher predictor or better predictor of the attitude towards free trade. And this is in line with the prediction of the Action-Only model about the impact of trade on long-run earnings, which is, if you like, crystallized in the Stolper-Samuelson theorem. So, if you like to summarize it shortly, the Action-Only model gives you a prediction about the trade pattern based on the resources, the relative supply of resources that you have available. And the Stolper-Samuelson theorem is if you like, deducting or inferring a result from that HO theorem, how that trade pattern will affect the welfare of the factors in the country. This concludes the lecture on the Heckscher and Ole model.